You use your phone every day. You send messages, watch videos, make calls instantly. But here's the strange part. Your phone never connects directly to another phone, not even once. Every single message, every call, and every video you send travels through an invisible system that covers the entire planet, a system built from thousands of towers, complex timing rules, and constant handoffs happening faster than your brain can even perceive. This is knowlyx.education, and today we're breaking down how mobile communication actually works from the moment you press send to the moment someone receives your message. Let's start with the biggest misconception. Your phone does not broadcast to the world like a radio station. It whispers, and it only whispers to the nearest cell tower. Imagine the world divided into invisible zones called cells. Each cell is covered by a base station, what we usually call a cell tower. Your phone is always connected to exactly one tower at a time, the one with the strongest and cleanest signal. When you send a message or make a call, your phone converts your voice or text into digital data, just a stream of ones and zeros. That data is then broken down into tiny packets, encrypted for security, and sent as radio waves to the nearest tower. But radio waves don't travel infinitely. They get weaker with distance, they bounce off buildings, and they can interfere with each other. That's why cells are small in cities, sometimes just a few hundred meters wide. Keeping the cells small ensures your phone's signal can reach the tower clearly without having to shout. Once your signal reaches the tower, the real magic begins. The tower doesn't send your message directly to another phone. It sends it into the core network, a massive digital nervous system owned and operated by your mobile provider, like Verizon, AT&T, or T-Mobile. Inside this network, your data goes on a rapid journey. First, it's authenticated to make sure you are who you say you are and that you've paid your bill. Then, it's verified to check for errors. After that, it's routed, meaning the network figures out where in the world your data needs to go. Finally, it's redirected towards its destination. If you're calling someone in the same city, the network finds their current cell and routes the call there. But if you're messaging someone on another continent, your data might travel through thousands of miles of fiber optic cables buried under oceans before it even gets close to their phone. Now here's something most people never realize. Your phone is constantly moving even when you're standing perfectly still. The signal strength fades and returns. Interference from other devices changes. People walk by, cars pass. The environment is never static. Because of this, your phone is constantly measuring the signal quality from nearby towers multiple times every single second. As soon as another tower offers a stronger, cleaner signal, the network performs what's called a handover, seamlessly switching your connection to a new cell without dropping your call or interrupting your download. This happens so incredibly fast that you never notice it. But during a single phone call while you're walking down the street, your connection might switch towers dozens of times. This handover process is why you can have a perfectly clear conversation while driving on a highway at 70 miles per hour. Your call is being passed from tower to tower like a baton in a relay race, all perfectly timed and coordinated by the network. Now, let's talk about the different generations of this technology: 2G, 3G, 4G, and 5G. These aren't just marketing terms, they represent fundamental shifts in what these networks can do. 2G was the first digital standard, and it was built for one thing: voice calls. Data was an afterthought. 3G was the next step, adding enough data speed to make basic internet browsing and email on a phone possible. 4G, also known as LTE, was a huge leap forward. It turned your phone into a true pocket computer, enabling high-definition video streaming, fast downloads, and the app ecosystem we rely on today. And then there's 5G. 5G isn't just about faster internet. It's a complete redesign of how mobile networks think. Instead of one general signal for everyone and everything, 5G can create virtual lanes. Think of it like a highway with dedicated lanes for different types of traffic. 5G can create separate, prioritized channels for high-definition video streaming, competitive online gaming, autonomous cars that need instant data, remote medical devices, and critical emergency services. With 5G, latency, the delay between sending a signal and receiving a response, drops to just a few milliseconds. That means near-instant response times, which is crucial for things like self-driving cars or remote surgery. But here's the trade-off for all that speed and power. Higher speeds require higher frequencies of radio waves. And higher frequencies have a big limitation. They travel shorter distances and they really struggle to pass through solid objects like walls, trees, and even rain. That's why the rollout of true high-speed 5G requires many more small antennas, often called small cells. You'll see them on buildings, street lights, and even inside large venues like stadiums and shopping malls. The network has to be much denser to provide consistent coverage. There's one more clever trick your phone and the network perform. Your phone doesn't transmit at full power all the time. If it did, your battery would drain in no time, and it would create massive interference for everyone else around you. Instead, the network is constantly telling your phone exactly how much power to use. Based on your distance from the tower and the current signal conditions, it adjusts your phone's transmission power up and down, second by second, to use the absolute minimum energy necessary for a clear connection. And yes, everything is encrypted. From the moment your voice or message leaves your phone, it's scrambled into a code. The towers and the core network can route this data. They know where it's going, but they can't understand what it says. Only the intended recipient's device has the key to unscramble it. So the next time you send a message and it appears on a friend's screen almost instantly, remember what just happened. Your phone didn't talk to their phone, it whispered to a tower, which sent your data on a journey through a global system of invisible cells, complex timing rules, and undersea cables, all before being reassembled on the other side in fractions of a second. And if this system fails, modern life simply pauses. If this made you see your phone a little differently, write your question or a topic idea in the comments. We read every single one. Subscribe to knowlyx Education if you want to understand the hidden systems that run your everyday life. Thanks for watching.